All right, what's up, everybody? We're in section 5.3 today, and we're going to begin looking at factoring techniques that can help us solve quadratic equations. All right, so in this video, we're going to focus on the techniques themselves, and then in a second video, we'll see how we can use the factoring in order to actually solve a quadratic equation. All right, so when I'm talking about factoring an expression, we have to understand that this means to write the expression as a product of two or more simpler expressions. So keyword here is product. That implies multiplication, right? So I've got some different examples here of expressions that have been factored. So starting with the real number 6, it has a factored form of 2 times 3. 2 and 3 are both considered to be factors of 6, all right? Then we have the variable expression x to the fourth minus 2x squared. It has a factored form of x squared times the quantity of x squared minus 2. You can check that these are in fact equivalent if you just distribute in the factored form. X squared times x squared would give you x to the fourth, and then x squared times negative 2 gives you negative 2x squared. The last example, you have a quadratic trinomial expression, x squared minus 4x minus 5. Notice it factors to two linear binomials, x minus 5 times x plus 1. So each binomial is considered a factor of the trinomial, okay? And once again, you can check this with the distributive property or foiling in the case of multiplying two binomials together. So the first part of FOIL is x times x, or x squared. The outside part of FOIL would give me 1x. The inside part gives me negative 5x. And then the last part gives me negative 5. And notice how the outside and inside parts of FOIL, those give you like terms, which ultimately leads you to the negative 4x in the trinomial there, okay? So let's just run through several different examples involving some factoring techniques, okay? So the first factoring technique you're always going to want to look for is a greatest common factor, GCF, all right? Get in the habit, anytime you're asked to factor an expression, always check for the GCF first. It can make any other factoring techniques that need to be used easier because it's going to make your numbers smaller, all right? So the expression of 2x squared minus 30 has two terms to it. Both of those terms, I would say, have a 2 in common and nothing larger. So the GCF here is 2. So I'm going to pull that out or factor it out by putting it in front here and then multiplying it by a binomial of x squared minus 15. And notice I can arrive at the x squared minus 15 by simply taking each of the terms in the original expression and dividing them by 2. Okay. The next expression is a trinomial, 3m squared x minus 6mx plus 12x. It has three terms, that are separated by the addition and subtraction signs. Those terms all have a 3 in common and an x in common. So I can put those together and say that the GCF here is 3x. All right. So once again, I'm going to factor that out. If I take a 3x out of 3m squared x, I would just be left with m squared. If I take 3x from negative 6mx, I would be left with negative 2m. And if I take 3x from 12x, I'm simply left with positive 4. Now again, you can check both of these factored forms by simply multiplying them out using the distributive property. That's the great thing about factoring, is you can always check. All right, moving forward. These two examples, we are factoring a quadratic trinomial, and the trinomial is going to be of this form: x squared plus bx plus c, where the a value is automatically going to be a 1, okay? Now, factoring trinomials of this form it really just comes from experience and knowing what the factors are going to look like. So I'm going to take you back a couple slides here, and we're going to focus on this guy right here. Notice in red we have a quadratic trinomial, and then notice the factored form of it is those two linear binomials added or multiplied together, okay? If quadratic trinomials factor, they're going to factor to two linear binomials like this, okay? And understanding how to factor is going to be based off of knowing how the foiling process from the factored form gets you back to the expanded form, okay? So we just want to recall that the first part of FOIL, x times x, that's what led you to this first term of x squared. The last part of FOIL, negative 5 times 1, is what leads you to this negative 5, the constant. And then finally, it's the outside and inside parts of FOIL that combine to give you the middle term of negative 4x. Okay, if you understand all that, you can you should be able to come up with your factors, pretty quickly. Okay. All right, so back to here. If I want to factor x squared plus 5x plus 6, I know that if it's going to factor, it's going to be two binomials, and they both have to start with x. Right? That's the only way I'm going to get a term of x squared when I multiply out. All right. Now, the numbers that I place after x in each factor, I know that first and foremost, they have to multiply to the constant of 6. So there's a couple possibilities for that. Could be 6 and 1, or it could be 3 and 2. All right. Which it is depends on the outside and inside parts of FOIL, whether or not they combine to 5x. Okay. And in this case, what's going to work is going to be the positive 3 and the positive 2. All right. Notice if I multiply this all out, again, first part of FOIL is x squared. The outside part would be 2x. The inside part would be 3x. The last part would be 6. And we want to notice that the outside and inside parts are combining to give you that middle term of 5x there. Okay. So this would be considered my factored form. All right, on the second example, what we want to recognize right off the bat is that all three terms have a 2 in common, a GCF of 2. So I'm going to begin by factoring that 2 out, and what's left over would be x squared minus 3x minus 28. So it's a slightly factored form, but not completely factored. Notice we have another quadratic trinomial where that a value is 1 again, okay? So I'm going to see if that factors further. If it does, I'll need to carry the 2 down, and then my factors, again, would be binomials that would both have to begin with x, okay? The numbers that I place after x, I know that they have to multiply to the constant of negative 28. Now, there's a lot of different options for that. Negative 28 could be the product of negative 28 and 1, or 28 and negative 1. Could be 14 and negative 2, negative 14 and positive 2, 7 and negative 4, negative 7 and positive 4. Which pair is going to work is simply going to be dependent on outside and inside parts of FOIL being able to lead you back to negative 3x. Okay, and I've done a lot of these, and I can tell you kind of a shortcut in trying to minimize the number of tests or trials that you do here is always test the numbers that are closer to each other first. So what I mean by that is I would say that negative 7 and 4, or 7 and negative 4, those are closer in value than 14 and 2, 28 and 1, okay? So test the closer ones first. So I'm going to put minus 7 there, positive 4 there. And if I were to multiply x minus 7 with x plus 4 out, that would give me x squared plus 4x minus 7x minus 28. Notice how those outside and inside parts take me back to the negative 3x there. So this should, in fact, be my final factored form. Okay. All right, our third set of examples, really the only thing that changes here is now my a value is going to be something other than 1 on the coefficient of the squared term, okay? Which really, that's just going to make for the possibility of more trials, but the overall approach really doesn't change from the last set of examples, okay? So 2y squared minus 3y minus 5. If it factors, the factors are going to have to be binomials. And this time, I would say that one of the factors has to be begin with 2y and the other one has to begin with y. That's the only way I'm going to get that first term to be 2y squared. Okay. Then the numbers that follow, 2y and y, I know that they have to multiply to the constant of negative 5. So that could be 5 and negative 1 or negative 5 and positive 1. Okay. So you just need to test those pairs in the different spots until you wind up with outside and inside parts of FOIL leading you to the middle term of negative 3y. What it should end up being is negative 5 there and positive 1 there, right? Again, multiply it all out as a check. First part of FOIL is 2y squared, outside part 2y, inside part negative 5y, last part negative 5. Notice how these are going to lead you back to that middle term there. So here is our complete factored form. Okay. All right, next 12x squared plus 7x minus 10. This one's going to be a little tougher. There's going to be a lot more possibilities to test here. Starting with 12x squared, it could be created with a 6x and a 2x, or it could be a 3x and a 4x, or it could be a 12x and an x. Okay, so lots of different options right there. And then the numbers that follow in the second spot of each factor, we know that they have to multiply to a constant of negative 10. So that could be 10 and negative 1, negative 10 and 1, 5 and negative 2, negative 5, positive 2. All right. Now, again, same suggestion as the last set of examples. I would test the 5 and the 2 before I'd test the 10 and the 1. Okay. And I would also test them using the 3x and the 4x first rather than 6x and 2x or 12x and x, just because of the fact 3x and 4x are closer to each other. Okay. So let's say maybe I try positive 5 here and negative 2 here. We'll notice the outside part of FOIL would be negative 6x and the inside part would be 20x. Those are not going to combine to my middle term of 7x. So that's not going to work, okay? So I'll flip around here. Maybe I'll do positive 5 here and negative 2 there. So the outside part of FOIL is now 15x, and the inside part of FOIL is negative 8x. 15x minus 8x does give me 7x. All right, so right there, off the second trial, I've got it. I don't even have to worry about testing 6x and 2x or 12x and x. Okay. All right, so at this point, I would like you to practice, okay? You're going to pause the video and you're going to try to factor the two expressions on the next tab here, or next sheet. Work through those and then come back and check your work with mine.